This is going to be the greatest physics project of all time. It's gonna include...
We don't need to do that. We don't need to do that. It's a bit too much. You can go away now. Physics is the scientific study of matter. Its fundamental constituents, its motion and behavior through space and time, and the related entities of energy and force. Now, I just read the Wikipedia definition. It probably didn't make too much sense, but let's dive a bit deeper. Physics is the most fundamental science out of its three brothers. We find the importance of physics in biology and in chemistry. The way our muscles work and the way reactions happen all have roots in physics. Now, physics is a complicated and infinitely big topic, but I'm going to be dwelling on these few topics: forces, energy, work, circular motion, momentum, and finally, motion. Let's start with forces. Isaac Newton. You might remember when an apple fell on his head, but he did much more than that. He fathered calculus, discovered gravity, and discovered fundamental principles we know today as the three laws of motion. Now, I can keep talking about how much Isaac Newton helped us, but then the video will be way too long. Let's just cut to the point. The three laws of motion are: the first one states an object at rest remains at rest, and an object in motion remains in motion at a constant speed and in a straight line unless acted on by an unbalanced force. Now, the second law states the acceleration of an object depends on the mass of the object and the amount of force applied. The third law states whenever an object exerts a force on another object, the second object exerts an equal and opposite force on the thing or person exerting the force. The laws might sound complicated for some, but honestly, Isaac Newton was using fancy terms for the show of it. The first law of motion states that if an object that is not moving will not move, and an object that is moving won't stop unless some force acts on it. I have no idea why it took one of the smartest people on earth to figure that out, just to figure out that an object will keep moving if nothing happens to it. Newton's second law of motion is a bit less common sense. It states that the product of both the mass and acceleration is equal to the force. The rule F equals to ma is formed using that logic. Now, Newton's third law of motion states that every action has an equal and opposite reaction. That means if I push a wall, the amount of force I put on the wall is putting the same amount of force on me. Enough talk about forces, and let's talk about our second topic, energy. Energy's textbook definition is ability to do work, which is the ability to exert a force causing displacement of an object. You will realize this trend that the definition of physics terms are always going to be complicated for zero reason. The definition states that energy is the force that causes things to move. There are many forms of energy, but I'll focus on gravitational potential energy, kinetic energy, and elastic energy. Gravitational potential energy is the mass of the object multiplied by gravity and multiplied by its height. This gives us the formula U equals mgh, where U here stands for gravitational potential energy, m stands for mass in kilograms, g stands for gravity, which is on Earth 9.81, and height in meters. Kinetic energy of an object is the form of energy that possesses due to its motion. We can find kinetic energy by using half mv squared. A very important principle to know about gravitational potential energy and kinetic energy is that they are inversely related. That means, as gravitational potential energy increases, the kinetic energy decreases. Now, we can see this by looking at this creature jumping from these boxes. As soon as he jumps, his gravitational potential energy is at its peak, and as he slowly makes his whimsical descent, gravitational potential energy decreases and kinetic energy increases. On to the final form of energy that I will be talking about, and it is elastic energy. Elastic energy is the mechanical potential energy stored in the configuration of a material or physical system as it is subjected to elastic deformation by work performed upon it. Now, that did not make any sense, and it did not make any sense to me too. But let's try and decipher this together. Every spring has its own spring constant, which we label as k. We can find k by using the formula negative F over x. F being the force, and x being the displacement. This all ties into the main formula for elastic energy, which is U here is elastic energy, equals to half kx squared. The x here being the change in position, otherwise known as displacement. Now I see you're using the resistance band. You are right now using physics to recover, more specifically elastic energy. As you are stretching the band, you are creating energy which you resist to strengthen the weak and small supporting muscles in your arm. Have you seen those videos with people with an open container filled with water and they spin it in a circle really fast and the water stays inside the container? Well, that's because of circular motion. In physics, circular motion is the movement of an object along the circumference of a circle or rotation along a circular arc. It can be uniform with a constant rate of rotation and constant tangential movement across a circular path or circumference of the circle. The direction in which velocity or acceleration goes changes constantly. The moving object is undergoing acceleration by centripetal force, which is the force that keeps the object going in a circular path. Without the acceleration, the object would move in a straight line. This ties back to Newton's first law of motion, which states that an object in motion will stay in motion unless acted upon by an unbalanced force. In this case, the unbalanced force is just simply the centripetal force. As all things in physics, there is a rule for it. Centripetal acceleration is equal to velocity squared over the radius at which the object is orbiting. Centripetal force also has an equation, and it is mass in kilograms multiplied by velocity squared in meters per second over radius in meters. Now let's go back to Ed. Ah yes, he's trying the trick he found. He has his doubts about the video. Let's see if it works.
Your physics didn't work!
See? It does work. And that is because of physics. This car is moving. It might not look like it, but it is moving. The reason why we can't see the motion is because we don't have a point of reference to see if it is. See? It was moving all along. Now, what is a point of reference? It is a place or an object used to determine if something is in motion. The car did not appear in motion until a point of reference was placed, and we were only then able to conclude that it is in motion. Speed is the distance traveled by an object over the time it took to reach that distance. Let us say, Ed is on a treadmill. He walked a total of 200 meters and it took him 50 seconds to reach this distance. This means that his speed was 200 over 50, or 4 meters per second. Velocity is different from speed. Velocity is the quotient of displacement over time. Displacement is different from distance, as distance is the length of the path taken by an object, while displacement is the distance between the starting point and the ending point. Now let us go back to Ed. Ed wants to find his velocity on the treadmill. So he goes and does the same experiment, but if you said his velocity is 4 meters per second, you are wrong. Since Ed is running on a treadmill, he did not move from his current position. This means his displacement is simply 0. Not only that, you have to state the direction you are going with the velocity, as it is a vector quantity, so direction does matter. Acceleration is defined as the rate at which velocity changes over time. You can find the acceleration of an object by simply getting the quotient of the change in velocity over time. What is change in velocity? It simply means getting the final velocity of an object and subtracting it from the initial velocity. This gives us the total change in velocity. Now, let's check back on Ed. Ed's now running and wants to find his acceleration. He runs at a constant velocity of 5 meters per second, then changes his velocity to 6 meters per second. We can find his acceleration by doing his final velocity minus his initial velocity over the time taken, which gives us the acceleration of 0.1 meters per second squared to the left. Let's talk about work. Not that work. I mean work in physics, man. Work is the energy transferred to or from an object via the application of force along a displacement. When you push a box and the box moves, you are doing something called work. Work is a measurement of energy, so it uses the unit joules. To get work, it is the product of force multiplied by displacement. What do we have here? Isn't this weight too heavy for you? Fine, go ahead. You do realize you didn't do any work. Since the bar didn't move, there is no displacement, which means even if you exerted 1,000 newtons of force, the displacement is still equal to 0. When you pull an object in a straight line, it feels much easier than pulling an object at an angle. Why is that? When you pull an object at an angle, you aren't using the whole amount of force you are exerting. That's why we multiply force times the distance times the cosine of the angle you are pulling at. Let us use an example. Iyad is pulling this rope with a force of 100 newtons, and he dragged it 10 meters. And he is pulling it in a completely straight. The angle is 0. To find the work here, we can multiply the force times the displacement, which gives us 1,000 joules. Now, in this other example, since he is pulling the rope at an angle, we're going to need to use trigonometry to find the work done. We're going to multiply the force, which is 100, with the distance, which is 10, and multiply it with cosine 30 to get the work done, which is 866 joules. On to our final topic, momentum. Do you see when people run at very high speeds and they want to come to a stop, they have to slow down and they can't completely stop at the instant that they want to stop? This is because of momentum. Momentum is the quantity of motion of a moving body and is calculated by multiplying the mass of the object with its velocity. Okay, for the final time, let's check back on Iyad. Iyad over here is running at 6 meters per second, and his mass is 77 kilograms. To find the momentum, we're going to multiply the speed with the mass of the object. The object here being Iyad. This yields us 462 Newton seconds, or kg/ms. So I interviewed some students at our school and asked them a couple of questions about physics. Now let's see what they answered. Okay, please have your name.
My name is Leila.
I'm Mohammed Hisham.
My name is Habiba.
My name is Alia Amin.
Physics, in my own terms, is the study of forces of nature like gravity, law of motion.
Well, physics is one of the branches of the natural sciences alongside chemistry and biology.
It's a type of science that relates to like mathematics more than biology or chemistry, but it's like about how the world works around us.
Physics is the math behind all sciences, and it is the study of basically how everything works.
Isaac Newton was a physicist that was like mostly known for discovering gravity because of the apple that fell on top of his head. Isaac Newton is the scientist who discovered gravity when an apple fell on his head.
Isaac Newton is the human being that discovered gravity when an apple fell on his head.
He's one of many mathematicians back in I believe around the 17th century, like 1600s. I also believe in England. I'm not entirely sure the historical background, but he's most famously known for revolutionizing the idea of forces, especially the gravitational force.
Energy is basically the ability to do like anything, whether it's like thermal energy, kinetic energy, and etc. Or nuclear energy even.
Energy is like the ability to do work, There are many different types of energy. We have kinetic energy, potential energy, and elastic energy, and we can see them in many different ways throughout our daily life.
It's just the ability to perform work.
Well, from my understanding of energy, it's something that's constant, that can't be like destroyed, but only passed down from one thing to another, and it's usually in like a form of like light or energy, I'd say.
Honestly, personally, I love physics because it's like interesting and it's like straightforward. You just calculate stuff, and like it's interesting. And also, I like to understand how things work like in depth. So I find it a very interesting subject.
I dislike physics. I've never had a passion for physics compared to bio and chemistry. I like those two subjects, but not physics.
It's just not like really for me. I'm more interested in biology and chemistry.
I mainly take it like I chose it like between biology and physics. I chose like physics because I think I'm like more familiar with it. Like being out of familiarity, like compared to biology and physics, I chose physics out of familiarity. Since in my spare time I usually like watch like a few like videos of physics just for fun, like not for specifically educational purposes.